Okay, so the first example that we're going to look at is where we have a bunch of jobs, or basically a bunch of events or intervals that have a start time and an end time. And two jobs are compatible if they do not overlap. So for example, job A and job G are compatible because there's no overlap between them, but jobs B and C are not compatible. And for this problem, we want to find the maximum number of jobs that we can take together so that they're all compatible with each other. And you can see that they've highlighted the answer. The answer is jobs B, E, and H because they're all compatible with each other. And the maximum number of jobs that we can take together in the subset is going to be 3. So that's the problem we're trying to solve. And you can see how this may be applicable. Let's say you own a venue and you rent out rooms to people who want to host events, and you want to figure out the maximum number of events you can host in just one room. This is where this greedy algorithm could be applied for this particular problem. So I will say that all of these problems do involve some form of sorting the intervals and then picking them. And we're going to take a look at how we might be able to solve this problem. So some things we can consider to solve this problem of figuring out the maximum number of compatible events we can take is we could consider sorting the events by the earliest start time. So we could order them by earliest start time, and A has the earliest start time. So then we can say, okay, let's pick A. A is going to be one of the events we take. And then the next earliest start time that's compatible is going to be G. Because B, C, D, E, and F all overlap with A, the next compatible one is G. So we may say, okay, we'll take G because that has the next earliest start time. But you can see that if we take A and we take G, those are the only things we can take, which means that we only have 2 compatible jobs instead of 3, which is actually the answer. So you can see that sorting the intervals by earliest start time is not going to work for this particular example. Why am I getting so many notifications? So what I want you guys to do is I'm going to share my screen in just a second, but take a look at those bullet points and some possible solutions or approaches to a solution and try them out. Try to see which one of these will work. And then when you're ready, you can type into the chat. I'll give you guys about a minute to do that. So here are the intervals, and we want to figure out the maximum number of intervals we can take that do not overlap with each other. And these are some possible templates that may work, but only one of them works, so just try them out. Okay, if you're ready to share your thoughts, you can unmute your microphone so you can type into the chat. Which one of these do you think will work? And which ones do you think will not work? So we already discussed that the earliest start time does not work because if we choose A and G, that's only 2 jobs. But the answer is 3, B, E, and H.
For the same reason, the earliest finish time doesn't work because you'd still only get 2 jobs, H and D.
Okay.
Um,
Are there any other observations or comments that people want to share?
some combination of shortest interval and fewest conflicts would certainly be nice because that seems like what you want. You want the jobs that don't conflict with other jobs, but don't take too long, as to allow you to find other jobs.
Yeah, that's another good idea. Does anybody else have any ideas? Okay, so now I'll reveal the solution, and you can probably figure out what it is based on the counterexample that's not present. So the solution is to actually sort the intervals by the earliest finish time. And before I get to that, let's take a look at some counterexamples for why the other templates are wrong. So if we choose intervals based on the earliest start time, you can see we have this really huge interval that has the earliest start time. And if we were to choose the one with the earliest start time, we'd only get 1 as our answer. Whereas we could have gotten 4, these 4 over here, which is actually correct. If we chose the shortest interval, like in this case, our answer is going to be one. Whereas if we chose, whereas the actual answer would be two, because we could choose this interval over here and the second one over here, since they're compatible with each other. And here's another counterexample for diffuse conflicts, because instead we could have chosen these four intervals, which are all compatible with each other. There's no overlap. But if we were to choose the one with the fewest conflicts, that would give us just this. And the reason for why it's the earliest finish time is a little intuitive. It's because if we choose the interval that has the earliest finish time, that leaves the most amount of time afterwards, after it ends for the other intervals. So if we choose something like B has the earliest finish time, as you can
Oh,
see.
my bad.
That
I thought
leaves
it
the
was.
most
I
amount of
thought it was
time after B ends to choose other intervals. And that's why for this particular problem of finding the maximum subset of compatible jobs, you want to sort the intervals by the earliest finish time. So the way that would look is we have B with the earliest finish time, and we would take room B. And then we look at the next one, C has the next earliest finish time, but it's not compatible with B. There's overlap. So then we go to A, but again, there's overlap. And then we go to E, and E works. So then we add E to our answer. So now we have two rooms so far. And then we continue doing that. D is the next earliest finish time, but it's not compatible. F is not compatible. G is not compatible, but H is. And so our answer is three. We would take intervals B, E, and H. Are there any questions about this problem? And there are multiple solutions for this problem. There's not, in this case, there's only one solution, but there can be multiple solutions. And if there are multiple solutions, where maybe there's a solution where the intervals are not, or you didn't choose the intervals based on earliest finish time. And if that's the case, then what you can do is, if there's a job I of t plus, let's say you choose, let's say this is the arrangement that you choose. Okay, and this is the arrangement that happens when you choose the intervals by the earliest finish time. But there's this other way that you chose that's also possible. If there's an interval over here that ends before this interval over here, then we know for a fact we can replace this blue square over here, this blue interval, with the one that ends earlier, and we're still going to get the same answer because it ends earlier. And in fact, it may end up giving us a better, it may end up giving, we make it a better answer by choosing this one instead, because it ends earlier and gives us more time for later intervals. So that's the intuition and solution behind the earliest finish time algorithm. We're choosing the maximum number of compatible jobs. Now, the next problem is also really applicable in real life. You basically have a bunch of events or lectures, jobs, and you want to figure out the minimum number of rooms you need to host these events. So like, once again, if you own a venue and you're renting out rooms for people to host events, and you have 10 events and you know when they start and the time that they end, you want to figure out the minimum number of rooms that you have to prepare and clean up to host those events. Because you can have 10 different rooms, one room for each of these lectures or each of these events, but that's not optimal. Maybe you want to have a fewer number of rooms. So in this arrangement, the four rooms are required, but the actual answer is three rooms if we optimize it. And this is another problem that can be solved greedily with a greedy algorithm. So does everybody understand this problem that we're going to discuss now? You basically have a bunch of intervals and you want to figure out the minimum number of rooms you need to contain all of these intervals. And intervals in the same room cannot overlap. So for example, E and G cannot be in the same room because they overlap. That's why they're in different rooms. And once again, here's our template. These are four possible solutions. Only one of them is correct. And what I want you to do is take a look at these intervals over here and the options provided and try to figure out which ones will work, which ones may not work, and just make some observations about that. And in about a minute, we'll discuss it with each other. Okay, does anybody want to share what they've found out so far? Does the earliest start time work for this problem? Okay, I'll just go ahead and
I'd
explain it.
like to share an observation.
Mhm.
Um, I believe the optimal solution is one where the number of classrooms is the same as the most conflicts, because you can't have multiple, because obviously you can't have multiple events in the same room. That was one of the, you know,
Yeah,
that
yeah, that's
was
a
one
really
of
good
the,
observation.
but
But
as you saw, the other one with four classrooms, you could have there would be a way to put E in the first one and move rooms around until you found so yeah, the other
yeah, so what
but
Matthew said is the max.
yeah, go
Sorry,
ahead.
somebody speaking.
That was me. Sorry, go ahead.
Yeah. So what Matthew said was the minimum number of rooms that we're going to need is the maximum number of overlaps at any given time. So you can see at time 10, there are exactly three overlaps. At time 11:30, there's three overlaps. At every single time, there are at most three overlaps. If H had started a little earlier at 1:30, then at time 1:30, there would be four overlapping intervals. So we need at least four rooms. But as it is, at most, there's only three overlapping intervals. And that's why the answer is three. But to figure out where we would assign these rooms, the algorithm that we would choose is the earliest start time. And once again, we're going to look at some counter examples for why the other ones are not wrong, for why the other ones are wrong. So if we chose to sort the intervals by the earliest finish time, we see that this interval over here has the earliest finish time. This has the second earliest finish time. This one has the third earliest finish time, and this one has the fourth earliest finish time. So what we do is we'd add this to its own room. This has the next earliest finish time, but since they're not compatible, it gets its second room. It gets a room by itself. This has the third earliest finish time, and it's compatible with room one. So we add it to room one. And this one has the last earliest finish time. It finishes the latest. And because it's not compatible with rooms two or one, because it has these two intervals, it overlaps with them. It gets its own room. But the answer is actually two. So this is why earliest finish time does not work. Here's an example where shortest interval does not work. You would add this interval to room one. This interval would overlaps with this interval, so it gets its own room. This one, this one is the next shortest interval, and it's compatible in room one because it does not overlap with this small one over here. But then this one, which is the largest, overlaps with room two and room one, so it has to get its own room. And similarly, fewest conflicts also leads to an unoptimal assortment of the intervals. So the answer to get this correct is to sort the intervals by the earliest start time. And when you sort the intervals by the earliest start time and you have your list of intervals sorted by the earliest start time, all the intervals after a certain position are going to start at the same time as their current interval, or they're going to start after it. And you can use this fact because all of the intervals eventually have to be assigned to a room. And when you assign an interval to a room and you know that all the intervals that follow in the list start sometime after it or at the same time, you can easily compare the two intervals to check whether or not they overlap. And then if the two intervals overlap because the start time of one is between the duration of another, then that interval which overlaps has to get its own room. And so when you sort these by earliest start time, you have A and C that are tied. A, B, and C are tied. Then you have D and E, F and G, H, and then I and J. So I'm just going to go alphabetically if there are ties. So interval A would get its own room first. Interval B has the same time as interval A. And because we've sorted by earliest finish time and we know this, we know that B has to get its own room. It can't go in the same room as A. Same thing with C. It can't go in either rooms one or two, so it has to get its own room. And then with room D, that's the next earliest start time. Because we know that D starts sometime after all of these three intervals, we just have to check whether it starts after the finish time of these rooms. And D starts after the finish time of C. So we know that C and D are compatible and we can put it in room 3. And we just continue doing this, and then we get the optimal arrangement of 3 classrooms as shown in the diagram over here. And so for this particular problem of figuring out the minimum number of classrooms that we need, the earliest start time is going to be the answer. That's going to be how we sort the intervals and process them. And there's one more example we're going to cover today. Yeah, this is what Matthew was talking about the depth of the intervals, like the maximum number of overlapping intervals. The next one that we're going to talk about is also applicable. This is where you have a bunch of jobs that you have to complete. And each of these jobs has a duration that it takes to complete them, the amount of time, and that's given by T of J. And they also have a due date, which is given at D of J. So this table over here just summarizes these intervals. Interval 1 takes 3 hours to complete, and interval 1 takes 3 hours to complete and it's due at time 6. Interval 2 takes 2 hours to complete and it's due at the 8th hour, and so on. That's basically what this table tells us. And what we would need to figure out for this problem is we want to find a way to schedule all the jobs that minimizes the maximum lateness. So the lateness is defined as when the assignment was turned in minus the due date. So let's just look at some examples. Over here, we have this first interval that was due at time 6. So this interval over here, given by this little rectangle, was due at time 6, but it was completed, it was finished at time 8. So that's the lateness of 2. This interval over here was finished at time 11, but it was due at time 14. So this is a lateness of 0 because it is not late. But this interval over here was due at time 9, like all the way back here, but it finishes at time 15. So that's a lateness of 6. And we want to figure out, and the max lateness for this whole assortment over here is going to be 6. We want to find a way to organize these intervals so that the maximum lateness is minimized. And you can once again see how this is applicable. Maybe you have some homework assignments that take a certain amount of time to do, and they're due at certain times that you're also given. And you want to figure out which order to do the homework assignments in so that the maximum lateness is minimized. And once again, let's take a look at some possible ways to sort these intervals. One thing we may consider is sorting them by shortest processing time first. So for example, this interval over here takes the least amount of time to do. This job takes 1 hour to do. This job takes 2 hours to do. Another thing we may consider is the earliest deadline. So over here, interval 1 is due first at time 6, then interval 2 is due at time 8. And the third thing we may consider is the smallest slack. And slack is basically when the assignment is due minus how long it takes to complete it. So for example, interval 6 gives us a lot of slack because it only takes 2 hours to do it, and it's due 15 hours later. So this has the most slack, whereas something like interval 1 has the least amount of slack. So just like before, take a look at these intervals and the possible templates that may be solutions. Once again, only one of them is correct. And just try to make some general observations and try to figure out which one is correct and which ones are wrong. And we'll discuss it in about a minute. Okay, so are there any observations?
When you only showed the first two, I was thinking that it had to be a combination of the two. So then when you introduced Slack, I thought that must be the correct answer.
Yeah, that's a good idea. Slack may seem correct because if an interval is due at a certain time and very far in the future, but it only takes a little amount of time to do, then maybe you want to put it off until later. Okay. Are there any other thoughts? So I want you guys, everybody has to participate, and you can guess, it's fine if you just make a random guess. But if you think the answer is this one over here, shortest processing time, I want you to type 1 into the chat and press enter. If you think it's earliest deadline, type 2 and hit enter. Otherwise, if you think it's smallest slack, press 3 and hit enter. And I want everybody to do that. You can make a guess, it's fine. Okay, so far everybody has said 3, but the solution is actually number 2. You would want to sort them by the earliest deadline first, because if something's due maybe in an hour or 2 hours, you want to get that done as soon as possible. And we look at the counter examples to see why the other 2 options are wrong. So with the shortest processing time first, we have this assignment over here that only takes us 1 hour to do. I keep saying due because D of J is due. It takes us 1 hour to do, but it's due at time 100. And this job over here takes 10 hours to do, but it's due at time 10. But if we were to choose the jobs based on shortest processing time, we would choose job number 1 over here, even though it's due very far into the future. And so job 2 would become late because we'd have to put it off until time 1, and we'd finish it at time 11, which is 1 hour late. So that's why shortest processing time does not work. That's an example where it does not work. And here's an example where smallest slack does not work. So for over here, we have an assignment that takes 1 hour to do, and it's due at time 2. And we have an assignment that takes 10 hours to do and is due at time 10. Because this one over here has the smallest slack, if you were to use the smallest slack algorithm, we would do a job 2 first because it has the smallest amount of slack. And we'd do job 2 and we'd finish it at time 10. And there's no lateness, that's fine. But then if we start job 1 at time 10, we're going to finish it at time 11. So you finish job 1 at time 11 and it's due at time 2. So that's 9 hours late, which is not good. It's 9 hours late. Whereas if we'd done job 1 first, we would get that done very quickly because it's due. It takes 1 hour to do, and our lateness would only be 1. Yeah, so the slack may be a little misleading because you may have something that's takes a really long time to do, and it has 0 slack, and you may have something that's really small. It happens really quickly, but it's due very far into the future. And if you take the one with the smaller slack but takes a really long time to do, you may get a lot of lateness. So the solution is to do it by the earliest deadline. And you can see over here, this is the same example as above with the earliest deadline. And this also seems kind of intuitive. I think somebody said that if it's like 3 is kind of a combination of 1 and 2, you want to choose it by the earliest deadline because if something's due, if you have a bunch of jobs and job 1 is due before all the other jobs, you want to get job 1 done first, and then the job that's due next, and then so on. So in this example, we can see that job 1 is due at time 6, so we're going to do it first, and then we're going to do job 2, which is due at time 8, and then 3, and then 4, and then 5, and 6. And with this assortment, the maximum lateness is going to be 1 because this job was due at time 9, but we finished it at time 10. So 10 minus 9 is 1. And everything else is fine. It finishes before or at the exact time that it's due. And that's why we'd want to do it by earliest deadline. So that's how we'd minimize lateness. And are there any questions about any of these 3 examples that we covered? Okay, so now that we covered the logic behind them and how they work, how we would approach the problem, you guys may be wondering how we'd actually code it. So we're going to go ahead and do some hands-on programming. So you can pull up REPL or whatever you use to code. And we're just going to go over a basic example. We may not go over it all the way. We'll just do the first one that we covered, which is figuring out the maximum number of intervals we can put in one room. So you can see here, I just have a file open. I'll give you guys about 10 seconds to pull something up, whatever you're using to code. And I recommend that you code along. That way you can get more practice. And if you run into errors or you have questions while you're coding, you're able to ask now. Okay, so how do you think we can represent these intools? We can use an array to represent them because there's multiple intools, so we can use an array. But there's not just like one integer associated with each of these intools. There's two of them. There's a start time and there's a finish time. So we can't exactly have an int array for the intools because there's two ints that we're supposed to store. So does anybody have any ideas for what we can do to represent an intool?
A map?
Yep, we can possibly use a map.
Oh, wait, that won't work. That won't work.
Yeah, but there may be some things with the same start time. A 2D array is also possible. Yeah, it could be like, let's say we had 10 intools, and it could be like 10 by 2, I guess. But if we
Wait,
also want to sort these intools, the information is going to have to stay together. So the answer is we're going to have to create our own class to store these intools. So we'll create a class outside of our main function. We'll call it event. And each event has a start time and a finish time. For its constructor, we'll just have public event. And the constructor will take in two numbers, the start and finish time for this interval or for this event. So we'll just say start equals S, finish equals E. And now that we have this basic class over here, I'll just copy and paste it. Now that we have this basic class, we can come over here to our main function and create an array of events. So we'll say events equals new event. I guess I'll have 1, 2, 3, 4, 5, 6. I'll have an array of 6 events, and events of 0 will be a new event, and it will start at time 1 and end at time 7. Events of 1 will be an event that starts at time. Well, actually, to do this, to make it shorter to type, I'll just have a start time array. And that's going to be equal to 1, 3, 8, 10, 2, and 14. And I'll have an end time array that is going to be 7, 9, 13, 15, 11, and 17. And now what I'll do is I'll just go through each of these and I will create a new event. Events of I will be a new event, start time of I, end time of I. So now our events array has 6 events and the start times and the end times are over here in the array. And now we want to sort these events, right? Because that's the whole thing we discussed. The whole solution to the problem, one of the main components of the solutions to these problems we've discussed is actually sorting them. So to sort this array, we could say arrays.sort events. And this will sort it, but it's I'm not sure how it will sort it because this is an event object. And in order to specify how we want it to be sorted, we have to implement the comparable interface. So remember, this is something that Kanishk and Madhu covered a couple of months back. The video is on YouTube and the code is on Google Classroom. What's wrong here? Yeah, so wait, what am I saying? It implements comparable event, yeah. And you can see this is in red because we have to implement the method compare to. And this basically tells when it's sorting the events, it needs to know if you have 2 events, it needs to know which one will go before the other. So we want an event to go before the other. In this case, if it has an earlier finish time, because remember, the problem that we're trying to solve is the maximum number of compatible intervals we can take. So we'll just say return finish minus o.finish. And it's either this or o dot finish minus finish, but we'll just run it later and we can change it if needed. So now that we have this, just to make sure that the intervals are correctly sorted, I'm going to iterate over them again. And I'm going to print out their start and end times. And we want the intervals to be sorted by the earliest finish time. So we'll just run this and check if it works. And here's the code for the events class. Yeah, it looks like it worked. You can see that it sorted all of these intervals by the earliest finish time. 7, then 9, then 11, then 13, then 15, then 17. So now that we have these intervals sorted, if we want to figure out the maximum number of compatible events we can take, int max compatible, I'll just call it answer. What we're going to do is we're going to iterate over the array. And we will have int last time equals 0. So what we'll do, what we'll do is we'll check if, so we're going to go over our array and we want to check if this current interval does not overlap with the previous interval, then we want to add it to our answer. So to do this, we would say int last end equals 0. So if events of I dot start is greater than or equal to last end, this interval is compatible because its start time is after the end time of this interval of our previous interval that we chose. Then we're going to increase our answer by 1, and we'll say last end equals events of I dot end dot finish. And now we can print out our answer. We'll just check if this is correct. Max intervals and run this. Okay, and you can see it printed out 3 because the maximum number of intervals that we can take is 3. And we can also have it print out which intervals we should take. So we can say we can print out events of I dot start plus events of I dot finish. And if we do this, it'll also tell us which events we should do. So you can see it printed out 1 and 7, 8 and 13, 14 and 17. Because those 3 intervals are all compatible with each other, and these are the maximum number of compatible intervals we can take together. So are there any questions about this code and how it works? And then the main thing that I wanted to cover is how to create this events class, because based on the problem, you may have to have a different, you may want to, you're definitely going to have to sort the events, but based on the problem, maybe you have to sort them by start time or finish time. And I just wanted to cover how to create this events class and create the compare to method that we can sort them. And this is an example of coding the solution to choosing the maximum number of intervals that you can take. And I think that's pretty much it for today's meeting. If you have any questions, you can stay behind and ask, but otherwise, thank you for coming.